Hey there! Tonight we're going somewhere only one spacecraft in the whole of human history has ever been. Straight up, over the top of the Sunday. It's the strangest blind spot we have, because rising above the solar system actually costs more than leaving it. So everything we've ever launched, every probe, every lander, every telescope, has slipped out sideways instead. Which means that right now, straight up through your ceiling, past the moon, past every planet, there's a whole half of the universe we've barely ever touched. And here's the part almost nobody knows. The flat solar system from your school posters is only flat up close. From far enough above, our home is wrapped in a sphere of 1 trillion sleeping comets, a snow globe the size of a small forever. So tonight, we're taking the trip nobody takes, one gentle layer at a time, until we find out what's really above us, what's really below, and why, at the very top, the idea of up itself quietly comes apart. If these journeys help you rest, a like or a subscribe is the kindest way to say so, and leave a comment with where in the world you're drifting off from. It's always bedtime somewhere. For now, dim the lights and settle in. I'll keep watch. Now, you're floating in a quiet little ship just above the sun, pointed in a direction no map ever shows. Let's begin. Before we can rise, it's worth asking a question that sounds almost too simple. Why is there an up at all? Why does the solar system have a top and a bottom to visit in the first place? Gravity, after all, doesn't care about direction. It pulls the same in every one. If gravity were the only author of our story, the solar system could have been a swarm, a loose ball of planets buzzing around the sun every which way, like moths around a porch light. And yet when you look at the real thing, you find something almost suspiciously tidy. 8 planets, dozens of moons, millions of asteroids, nearly all of them circling the sun on the same thin, invisible sheet, as if someone had laid a great glass table through space and politely asked everyone to stay on it. The reason begins long before the sun existed. 4.5 billion years ago, there was no solar system here at all, just a cloud. A cold, dark fog of gas and dust, drifting between the stars so wide that light itself would have needed years to cross it. And that cloud was turning. Barely. So slowly that if you had floated inside it, you would never have noticed. But in a universe with almost no friction, even the laziest spin is patient. It can wait forever, because nothing ever tells it to stop. Then, something nudged the cloud, perhaps the shockwave of a distant exploding star, and it began to fall inward on itself. And here is where the quiet spin took over the whole story. As the cloud shrank, it turned faster, the way a figure skater speeds up when she pulls her arms in close. She doesn't push harder. She just gets smaller, and the spin she already had has nowhere to go, so it quickens. The cloud did the same. What began as a drift became a swirl, and the swirl became a blur, and a strange thing happened to the shape of everything. Think of a ball of pizza dough. Toss it in the air with a spin, and it doesn't stay a ball. It stretches sideways, wider and wider, thinner and thinner, becoming a disc. It flattens because spinning things resist falling inward along one direction, the direction of the spin, but nothing stops them from collapsing along the other one, top and bottom. So the cloud fell flat, not because anything pressed down on it, but because the spin held it open in one plane and let it drain closed in the other. Within a few 100,000 years, an unimaginably short moment for the universe, the shapeless fog had organized itself into a bright young star wearing a wide, flat apron of gas and dust. Astronomers call that apron a protoplanetary disk, and we've now photographed hundreds of them around other infant stars, glowing rings and gaps, like tree rings around a point of light in the dark. Every one of them is a baby picture of us, because inside our own disk, dust grains were bumping into each other, sticking, growing, first into pebbles, then boulders, then worlds. And since all of them were born from the same flat sheet, they inherited the same flat manners. The planets never chose to line up. They simply froze an ancient spin into their bones, and they've been honouring it ever since. We don't have a photograph of our own beginning, of course, but the universe has been kind enough to leave the family album lying open. In the last decade or so, astronomers pointed a great array of radio telescopes, high in the Chilean desert, at newborn stars still wearing their disks, and the pictures that came back were so clean and so lovely that even the scientists were startled. The most famous shows a young star wrapped in a wide golden disk, and etched into that disk, dark concentric rings, gap after gap after gap, like the grooves of a vinyl record. Each gap most likely is a young planet, sweeping its orbit clean, clearing its own seat at the table. That image is a portrait of us, 4.5 billion years ago. Somewhere in a picture like that, in some gap in some ring, an unfinished Earth is quietly gathering itself, and nothing anywhere suspects that oceans or forests or sleepy people under blankets are on the way. And before we drift on, it's worth noticing something odd about your own seat at this table, something you've lived with your whole life. Earth rides the flat sheet like everyone else, but Earth itself doesn't sit up straight. Our planet leans. Its axis, the line through the poles that it spins around, is tipped about 23 degrees relative to the table, like a top that never quite stood upright. So even down on the ground, before any journey, your personal up, the direction out through the top of your head as you stand, doesn't agree with the solar system's up. The direction over the sun's pole, you have always lived at a slant, and that familiar lean is no small detail. It is the entire reason for seasons. As Earth carries its tilt around the sun, first one half of the world nods toward the light, then the other, and that gentle nodding is summer and winter, the whole calendar of harvests and snowfalls, all of it descending from one accident of tilt frozen in when the worlds were being built. The table gave us our orbit, but the lean gave us autumn. The table even sends us mail, on schedule, every year. Comets that visit the inner solar system leave trails of dust behind them, long rivers of crumbs that keep following the comet's old path, like a road of breadcrumbs around the Sunday. When Earth's orbit happens to cross one of those dusty rivers, we plough through it, always at the same points of our yearly lap, which means always on the same calendar nights. And on those nights the crumbs rain into our sky and streak a light, and we call it a meteor shower. The shooting stars of August, the ones of December, they are appointments, kept for centuries, made by the geometry of the table. When you catch a falling star, you are watching Earth drive through the litter of a comet's commute, right there on the Great Shared Road. That's why, tonight, all 8 planets still travel within about 7 degrees of one shared plane, the plane astronomers call the ecliptic. 7 degrees is nothing. Hold your arm out straight and tip it by 7 degrees, and a stranger across the street might not even notice. Mercury is the most rebellious of the 8, and even Mercury leans only that far. The rest hold flatter still. Even the sun itself plays along, its equator tilted just a whisper from the table its children sit at. Our solar system, measured out to Neptune, is billions of miles across, yet the planets stray so little from the sheet that if you shrank the whole thing down to the size of a dinner table, the entire family would fit inside a slice of space thinner than a stack of a few coins. If you want to see what spin does to matter, in miniature, you only have to look at the loveliest object in any small telescope. Saturn's rings are the same story told again, closer to home and faster. Countless shards of bright water ice, from dust grains to pieces the size of houses, all orbiting Saturn so obediently in one plane that the rings, though they span a distance most of the way from the Earth to the Moon, are in places only about as deep as a tall building. If you scaled the main rings down to the size of a sheet of paper, they would be thousands of times thinner than the paper. It is one of the flattest structures nature has ever made, hanging in the sky for anyone to see, and it flattened itself for exactly the same reason our solar system did. Collisions and spin, patiently ironing a cloud of pieces into a sheet. The universe, wherever it gets the chance, likes to press things flat and set them turning. Our whole solar system is simply Saturn's rings, written larger and slower. You've actually seen this flatness with your own eyes, whether or not anyone ever told you. It's why the sun, the moon, and every planet you've ever spotted all seem to travel along the same narrow highway across the sky. The ancients noticed that highway too. They watched the wanderers walk the same path through the same band of constellations, month after month, and they gave that band a name, the zodiac. They had no idea they were looking at the edge of a great disk from the inside. When you spot Venus glowing near the moon some evening, low along that old road, you are looking down the length of the table we all sit at. The flatness even writes itself into the calendar of eclipses. The moon's orbit is tipped by about 5 degrees from the ecliptic. Just 5. and that tiny lean is the only reason we don't get a solar eclipse every single month. Most months, the moon's shadow slips just above or just below the Earth, a near miss by a sliver of sky. Only when the moon happens to cross the table at exactly the right moment does its shadow land on us, and somewhere on Earth, day turns briefly into night. Whole civilizations kept careful count of those crossings. They were tracking, without knowing it, the small disobedience of one tilted orbit. So the solar system has a floor plan, and now you know why. Spin built it. A lazy rotation, older than the sun, flattened a formless cloud into a table, and set every world we know upon it. But notice what that means. It means above and below are not empty words here. They are real directions, as real as north and south, and they point at the two great territories our maps ignore, the space over the table and the space beneath it, the two views of home that almost nothing has ever seen. And so, gently, we lift away from the sheet and go looking at what the posters left out. The first thing you notice, rising off the table, is that the table's edges were never quite as tidy as the classroom version. Close to the sun, among the big planets, the discipline is strict, but scattered through the family are worlds that lean, and the farther out you look, the braver the leaning gets. It's as if the solar system keeps its well-behaved children near the dinner table and lets the wild ones wander the upstairs landing. Pluto was the first hint. When astronomers finally pinned down its path, they found an orbit tipped 17 degrees out of the plane, more than double the lean of any true planet, like a picture frame hung by someone in a hurry. For part of each long journey around the sun, Pluto rides high above the table where no planet ever travels, and for another part it dips far below, a small cold world spending centuries in the empty rooms of the solar system, and Pluto turned out to be only the beginning. Farther out drifts Eris, a world almost exactly Pluto's size, whose orbit leans a breathtaking 44 degrees, nearly halfway to standing on its edge. Eris spends most of its 500-year circuit soaring through territory so far off the map that, from there, the planets huddle together into a bright little line, the whole flat solar system seen edge-on, like a distant shelf of lights. Even the asteroid belt, that rubble ring between Mars and Jupiter, has its rebels. One of its largest members, a battered world called Pallas, swings more than 30 degrees off the table on every lap, plunging up and through and down again like a dolphin stitching through the surface of the sea. And then there are the comets, which hardly respect the table at all. The most famous one of all, Halley's Comet, doesn't just lean. It circles the sun backwards, against the flow of every planet, on a path so steeply tipped that calling it part of the flat solar system is really just good manners. Each visit, it dives through the plane, swings around the sun, and climbs away again. A pendulum crossing a doorway once every human lifetime. A few of the wanderers take the steepest road of all, the one that leads down. There is a whole family of comets, the sun-grazers, whose long tilted orbits plunge them almost straight into the sun, diving down out of the high dark, skimming the solar fire closer than any planet would dare, and swinging away again if they survive. Many don't. Our sun-watching observatories, keeping their patient vigil, have recorded thousands of small sun-grazers streaking in over the years and simply not coming out the other side, snowballs surrendered to the light. Most of them, wonderfully, seem to be siblings, fragments of one enormous comet that shattered centuries ago, its pieces still following the old family path down, one by one, decade after decade, like beads slipping off a very long string. The road above the table, it turns out, runs in both directions. Some travellers climb away into the dark, and some spend their whole lives falling toward the light. And in between all these travellers filling the space above and below the table with something softer, there is dust. The solar system is dusty in the loveliest way. Crumbs shed by comets, powder ground off asteroids in slow collisions, all of it spread into an enormous puffy cloud that hugs the plane of the planets but billows well above and below it, the way flour hangs in the air of a busy bakery. Each grain is a tiny mirror, and together they catch the sunlight. On a truly dark night, far from city lights, you can see them. After the evening fades, a faint pyramid of glow sometimes leans up from the horizon, following the old road of the zodiac. Before sunrise it can appear again, so pale and strange that desert travellers once called it the false dawn. That glow is the dust of the solar system, lit from within, the table's atmosphere made visible, and sunlight, patiently, is tidying it. Light itself presses on each grain, ever so slightly breaking it, so the dust slowly spirals inward toward the sun over thousands of years, and is forever replenished by fresh crumbs, a quiet housekeeping, running for billions of years. People have been noticing that dust glow for a very long time, longer than they've known what it was. Old Persian poetry speaks of the false dawn, the pale wolf's tail of light that lifts from the horizon before the true morning, and desert caravans learn not to trust it. Centuries later, one of the first great astronomers of the telescope age, Giovanni Cassini, studied the glow seriously and guessed, correctly, that it was sunlight scattering off a cloud of countless small grains gathered around the Sunday. It remains one of those rare sights that connects you, instantly, to everyone who has ever watched the sky. The same soft pyramid that puzzled shepherds and sailors is up there over your horizon tonight, unchanged, the table's quiet lamp. And the dust has an even stranger trick, one that almost nobody has seen. On the very darkest nights, in the very emptiest places on Earth, you can find a second glow opposite the Sunday. Face the midnight point of the sky, the spot directly away from where the sun sits below the world, and there, with patient eyes, a faint round paleness appears, hovering like breath. Astronomers call it the Gegenschein, the counterglow. It happens because each dust grain, at that exact angle, reflects sunlight straight back the way it came, like the eyes of a deer in headlights, like road signs flaring in high beams. Billions of grains, all catching the light at once, all bouncing it directly back past Earth, a halo of returned light, hanging at the anti-sun point of the sky. Most people live and die without ever seeing it. But it's there tonight, a secret second moonrise made entirely of dust. Earth, it turns out, even keeps some of this dust for itself. As our planet sweeps around its lap, its gravity gently herds passing grains, coaxing them into step, and over time, a faint ring of dust has gathered along Earth's own orbit. A subtle thickening of the glow that follows our planet around the sun like a path worn into a carpet. Venus appears to have one too. So picture the table again, truly now. Not bare glass, but a floor dusted with light, with brighter rings worn along the racetracks of the worlds, and pale lamps glowing at its edges. The solar system, seen honestly, is a lived-in room. So the space just above the planets is not a hard vacuum with a hard border. It is a fringe, a soft place, stitched with tilted wanderers and drifting powder, thinning gently as you rise. The table doesn't end. It fades, and once you've climbed above the last of the dust glow, you find yourself somewhere genuinely strange, a place with the sun blazing steadily beneath you. Which brings us to the most surprising fact of the whole journey, the reason this direction is so untravelled. Getting up here, to where you're floating now, is one of the hardest tricks in all of spaceflight. Here is something that sounds impossible, and yet the arithmetic of spaceflight insists on it. It takes less effort to leave the solar system forever than to fly over the top of the Sunday. We have hurled probes past Neptune, out beyond the planets entirely, and yet in all of history only one spacecraft has ever looped above the sun's poles. To understand why, you have to understand a gift, because every rocket that has ever left Earth received one at the moment of launch, whether it wanted it or not. The gift is speed. Earth is not sitting still. It is racing around the sun at about 19 miles every single second. Not per hour, per second. In the time it took you to hear that sentence, you, your bed, your whole sleeping town, travelled something like 40 miles around the Sunday. We never feel it, because everything around us is making the same journey, the air, the oceans, the moon, all of it gliding together in perfect silence. But any spacecraft that leaves Earth starts with that same enormous sideways motion baked in, the way a letter tossed from a moving train is already travelling at the speed of the train. For most missions, the gift is wonderful. Going to Mars, to Jupiter, to the edge of the solar system, you're gliding along the table anyway, so you simply add a little push to the speed you were born with and coast outward along the plane. But now, try to go up instead. Try to rise over the sun's north pole. Suddenly the gift becomes the problem, because all 19 miles per second of it points sideways, along the table, and none of it points up. To arc over the top of the sun, a spacecraft has to fight its own inheritance, cancelling the sideways rush and building a new one at right angles to it. It's like being on a fast-moving walkway and trying to leap cleanly over the handrail while the floor whips you forward. The walkway doesn't care where you'd rather go. You first have to undo everything it gave you, and undoing it is brutally expensive. Speed is the currency of spaceflight, and no rocket humanity has ever built can pay for that much change in direction with fuel alone. When engineers worked out the numbers, the conclusion was almost funny. We could send a probe clean out of the solar system more easily than we could send one over the Sunday. The territory above our star, closer to home than Mars in mere distance, might as well have been on the far side of the galaxy. But scientists wanted to see the sun's poles anyway, because the poles were a mystery. Everything we knew about our star, we knew from the side. Every telescope on Earth, and nearly every spacecraft, looks at the sun's equator, the same way you're always seeing a face in profile and never from above. So in October of 1990, a small European and American spacecraft named Ulysses left Earth to try the impossible route, and it did so with the only trick that could work. It flew away from the sun entirely. Ulysses travelled outward for a year and a half, out to mighty Jupiter, and let the giant planet do what no rocket could. Jupiter's gravity took hold of the little probe like a great hand, bent its path, and flung it downward out of the plane of the planets, into an orbit tilted almost straight up and over the Sunday. It's one of the loveliest bargains in all of spaceflight. The probe gave Jupiter a nudge so small the planet could never feel it, and Jupiter, in return, threw Ulysses over the roof of the solar system. And so, in the middle of the 1990s, a quiet machine the size of a washing machine did what nothing had ever done. It passed beneath the sun's south pole, swung up and around, and sailed high over the North Pole, looking down on our star from a place no eye, human or mechanical, had ever occupied. Here is a detail I find strangely moving. Ulysses carried no camera. There are no photographs from those passes. It flew over the poles of the sun in the dark, so to speak, feeling its way, tasting the wind. Because the sun has a wind, a thin, endless breath of particles streaming outward, and Ulysses discovered that above the poles, that wind blows differently. It comes out faster there, smoother, pouring from great open windows in the sun's atmosphere, while the slower, messier wind churns out near the equator. The probe circled on its tilted loop once every 6 years or so, a long, lonely ellipse from the sun out toward Jupiter's distance and back, and it kept faithfully reporting for almost 2 decades before it finally fell silent in 2009, still the only traveller ever to take the high road. There's a small poetry in the probe's name too. Ulysses was named not just for the wandering hero of the old epics, but for a scene in Dante where the aged Ulysses, restless at home, gathers his last crew and sails past the edge of the known world, hungry to see what no one had seen. The scientists who named the mission knew exactly what they were doing. Their Ulysses also left the known world, the flat, charted world of the ecliptic, and sailed into the unmapped sky above it. And what it felt up there rearranged our picture of the Sunday. Flying over the poles, Ulysses discovered that our star effectively has 2 winds. Near the equator, where all the planets live, the wind dawdles gusty and tangled, never quite settling. But over each pole the wind came pouring out at nearly twice that speed, smooth and steady, a clean fire hose of particles streaming from great dark openings in the sun's atmosphere, holes in the corona that stay parked over the poles for years at a time. Every planet, every person, lives down in the slow, messy weather. The sun saves its calmest, swiftest breath for the empty directions, for the up and the down where almost no one is there to feel it. Ulysses also found the sun's magnetism gently misbehaving, the field over the poles weaker and stranger than the tidy bar magnet picture in the textbooks, a first hint of how wild the sun's inner machinery really is. And because its long looping orbit kept bringing it back, once every 6 years or so, Ulysses got to see the poles in different moods. The sun has a pulse, a slow cycle of storm and calm that takes roughly 11 years, and the little probe flew its high passes across 3 of those seasons. It saw the poles in deep quiet, when the 2 wind patterns stood crisp and simple. It came back when the sun was in full storm, and found the tidy pattern dissolved, fast wind and slow wind tangled together at every height, like weather in a shaken snow globe. 1 spacecraft, 3 visits, and we learn that even the view from above the sun is never the same view twice. And the story has a quiet sequel unfolding right now. A newer spacecraft called Solar Orbiter is currently nudging its path a little steeper year by year, borrowing small boosts from Venus the way Ulysses once borrowed from Jupiter, tilting its orbit upward degree by degree. In 2025, for the first time, it climbed high enough to send back humanity's first real pictures of the sun's poles, the first glimpse of the view Ulysses could only feel. Slowly, patiently, we are learning to look at our own star from above. And what do the poles actually look like now that we've finally peaked? Strange, in a soft way. The first polar images show a landscape of magnetism unlike anywhere else on the sun, a patchwork of small magnetic regions of both kinds jumbled together, north and south mingled like warm and cool currents in a pond, rather than the settled, single-minded field you'd expect at a pole. The scientists were delighted, because that jumble is thought to be the sun's cycle in the act of resetting itself. The poles are where the sun's great engine turns over, where the old magnetic season is folded away and the new one begins, which is why astronomers wanted this view so badly for so long. Watching the poles is watching the sun's future being drafted. The quietest, least visited places on our star turn out to be its calendar. So as you float here tonight, over the sun's north pole, understand what a rare seat you occupy. Billions of people, 100,000 years of upturned faces, and this view belongs to a club so small it barely exists. The sun turning beneath you like a great slow wheel, the planets strung out around it on their glassy sheet, and everything humanity has ever done happening on that sheet, edge on, in a band so thin you could cover it with an outstretched hand. Up here, you begin to see the flat solar system the way a bird sees a river valley, whole and quietly small. And now that you've paid the price of altitude, the rest of the journey is easy. There's nothing left to fight. From here, we simply drift higher, outward and upward together, toward the frontier where the table itself begins to come apart. Out past Neptune, 30 times farther from the sun than Earth, the solar system stops being a diagram and becomes a wilderness. This is the Kuiper Belt, the attic of the solar system, and it is enormous, a ring of frozen worlds stretching from Neptune's orbit out to nearly twice that distance. Pluto lives here, along with its strange large siblings, and alongside them, astronomers estimate, more than 100,000 icy bodies bigger than a mountain range, plus countless smaller shards, the unused bricks and offcuts left over from the building of the planets. Out here, sunlight is weak, 0.01% of a summer afternoon, and temperatures sit hundreds of degrees below freezing. Nothing melts, nothing weathers, nothing changes. The belt is a museum of the original construction site, kept in the dark, under glass, for 4.5 billion years. But here is what matters for our journey. The Kuiper Belt is where the flatness begins to fail. The neat table that the 8 planets honour so strictly starts, out here, to soften and swell, like the edge of a well-used mattress. Some of the belt's worlds, the calm ones, still ride close to the plane, cold and undisturbed since the beginning, keeping the old discipline. But mixed among them is a wilder crowd, worlds on tilted, stretched, unruly paths, and their story is written right into their orbits. Long ago, in the solar system's rowdy youth, the giant planets shifted and jostled, and Neptune, wandering outward, scattered the small worlds around it, the way a big dog bounding through a flock of pigeons scatters birds into the air. Some were flung inward, some were thrown out of the solar system altogether, and many were simply tossed upward and downward, onto orbits that lean and dive. Pluto leans 17 degrees, and out here that's ordinary. Some of its neighbours lean 20-30 degrees. Eris, as we saw, climbs to 44. So if you could stand back and see the whole Kuiper Belt at once, every icy world with its path traced in light, you wouldn't see a thin sheet anymore. You'd see something puffed and generous, a swollen band, thicker than it is neat, less like a ring, more like a donut of frozen sparks wrapped around the distant Sunday. The flat solar system is quietly changing its mind out here. It took us a surprisingly long time to find this place. The idea came first, as ideas often do. In the middle of the 20th century, astronomers wondering where short-visit comets came from reasoned that a belt of leftover ice ought to exist out beyond Neptune. and the notion became loosely attached to the name of Gerard Kuiper in one of astronomy's small ironies, since he suspected such a belt would have long since scattered away. For decades it remained a guess. Then two astronomers, David Jewett and Jane Liu, decided to simply look. Night after night, year after year, they photographed patches of sky and compared the frames, hunting for one faint dot that moved. The search took 5 years. And in the late summer of 1992, from a telescope in Hawaii, they found it, a dim point of light creeping along beyond Neptune, the first new world of the belt. Jewett later said they'd been close to giving up. Within a few years, dozens more appeared, then hundreds, then thousands, and the empty space beyond Neptune quietly became the most crowded neighborhood in the solar system. And the belt is not a jumble. Listen closely, and it's a dance. Neptune's gravity, sweeping around and around for billions of years, has herded many of the belt's worlds into step, locking them into gentle rhythms. Pluto itself keeps the most famous beat. For every 3 laps Neptune makes around the Sun, Pluto makes exactly 2, a ratio kept so faithfully that the two worlds can never collide, their paths choreographed to always miss, partners in a waltz that has repeated for 4 billion years. There are whole families keeping Pluto's rhythm, and astronomers call them Plutinos, the little Plutos, an entire population of frozen worlds counting the same slow music. Farther out drift the truly untouched ones, the cold classical worlds, so undisturbed that many of them still travel in pairs, 2 lumps of primordial ice circling one another as they orbit, couples that have held together, unbothered, since before the Earth was finished. We even have a family portrait from the calm heart of the belt. When the New Horizons spacecraft raced past Pluto, it was sent onward to a small body called Arakoth, the most distant world ever visited, and found something wonderful. 2 soft reddish lobes, gently pressed together like a snowman leaning into a hug, so delicately joined that they can only have met at walking speed. In the flat, patient middle of the belt where the old order still holds. Arakoth is what the table looks like, where it's still a table. The leaning crowds above it are what happens at the frontier. The belt is not sealed away up there either. It leaks, gently, inward. Every so often, over millions of years, Neptune's gravity tips one of the icy worlds loose, and it begins a long, wandering descent into the realm of the giant planets. Astronomers have found hundreds of these in-between travelers, drifting on unstable paths among Jupiter, Saturn, Uranus, and Neptune, and they've named them centaurs, after the mythical creatures that were 2 things at once, because that is exactly what they are. 2 icy to be asteroids, not yet close enough to the Sun to grow tails and become comets. They are comets in waiting, spending a few million years in the hallway between worlds until the giant's gravity decides their fate, flinging some back out into the dark and passing others inward, where the Sun's warmth finally wakes them, and they bloom, at last, into the short-visit comets that grace our skies. Some of the comets our great-grandchildren will wish upon are up there right now, in the hallway, still frozen, still waiting for their names. And that is really the deep truth of this layer of the journey. Flatness, in a solar system, is a kind of closeness. Near the Sun, the old spin rules everything, and the family stays seated. But every step outward loosens the Sun's grip, and the ancient discipline of the disk fades like a habit nobody enforces anymore. The solar system doesn't end with a wall. It ends the way a formal dinner drifts into a garden party, the seating chart forgotten, the guests wandering out onto the lawn, and the farther up and out you drift with them, the more often you'll meet a guest who was never part of the family at all. Because the space above the table, it turns out, has travellers of its own, and one autumn night not long ago, one of them came down to visit. In October of 2017, on the summit of a dormant volcano in Hawaii, a telescope called Pan-STARRS was doing what it does every clear night, sweeping the sky for moving points of light. It found one, a faint dot drifting against the stars. At first it looked like any small asteroid, a routine entry in a long catalogue. But when astronomers traced its path backward, something didn't fit. The dot was falling through the solar system too fast, far too fast for the Sun to have ever owned it. Its path wasn't the closed loop of a comet or the ellipse of an asteroid. It was an open curve, a single pass, the trajectory of something that had come in from the deep and would never come back. It had entered from above, dropping down through the plane of the planets from the direction of the bright star Vega, and by the time we noticed it, it was already leaving. Hawaiian astronomers gave it a name that fits it better than any catalogue number ever could. They called it Oumuamua, a word that means, roughly, a messenger from afar arriving first. And it was strange in almost every way we could measure. It tumbled end over end. Its brightness rose and fell so steeply that it had to be wildly elongated, shaped like a cigar, or perhaps flat like a pancake, unlike any asteroid we'd ever seen. It showed no tail, no puff of gas, and yet, as it departed, it picked up a whisper of extra speed that gravity alone couldn't explain, most likely the gentle push of some invisible outgassing, though astronomers still argue happily about the details. The honest summary is this. The first confirmed visitor from another star was a genuine oddball, and it passed through so quickly, in a matter of weeks, that we never got a proper look. Somewhere out there tonight, it is receding into the dark with its secrets intact, carrying a Hawaiian name out among the stars. Just 2 years later, the second visitor arrived, and this time the discovery belonged not to a mountaintop observatory but to an amateur, a telescope maker in Crimea named Gennady Borisov. Scanning the morning sky with an instrument he had built himself, the object he found was also moving too fast to belong to the Sun, also on a one-way visit, but this one was wonderfully familiar. It was a comet, a proper honest comet with a glowing head and a soft tail, made of the same ices and dust as the comets of our own solar system, and that familiarity was its own kind of revelation. Around some other star, unknowably far away, nature had built comets by the same recipe used here at home. The second messenger's message was simple and warm. Other solar systems are made of the same things ours is. And then, in July of 2025, came the third. A survey telescope network built to watch for hazardous asteroids picked up a new fast-moving visitor, the third interstellar object ever confirmed, and the swiftest yet, sweeping through the inner solar system on its own open curve, while telescopes all over the world turned to watch. 3 visitors in 8 years, after all of recorded history without a single one. And that arithmetic tells you something lovely. We didn't get lucky 3 times. We simply learned to look. Astronomers now suspect that objects like these pass through the solar system constantly, perhaps several drifting somewhere inside the planet's orbits at any given moment, almost all of them too small and dark to notice. A slow, silent rain of wanderers, falling through our neighbourhood from every direction, from above the table and below it, each one a shard of some other star's construction site, thrown loose ages ago and drifting between the stars for millions of years before happening, briefly, upon our lamplight. Each of the 3 visitors, in its brief stay, told us something about the neighbourhoods it came from. Oumuamua, the strange first one, was small, perhaps a few 100 feet long, and it turned end over end about once every 8 hours. A slow tumble it had probably carried across the galaxy for millions of years, unchanged, because nothing out there ever touched it to slow it down. Astronomers have floated a whole bouquet of gentle explanations for its odd shape and its whisper of extra speed. A shard of frozen nitrogen shaved off some distant world like a sliver of soap, a comet gone quiet. It's pushing gas too thin for us to see. The honest answer is that nobody knows, and there is something restful about that. The universe is under no obligation to finish its stories while we're watching. Borisov, the friendly second visitor, stayed longer and shared more. When astronomers read the chemistry of its glowing tail, they found it unusually rich in carbon monoxide ice, a substance that only stays frozen in profound cold, which means Borisov was probably built in the far, dark outskirts of its home system, a snowflake from someone else's Oort cloud, which makes its visit feel almost like a greeting between shells. And the third visitor came in fastest of all, at well over 100,000 miles per hour, moving with the kind of speed that suggests a long, old journey. Some astronomers, reading the way it moved, suspect it may have been wandering the galaxy since before our Sun existed, older than the solar system it briefly crossed, a traveller from deeper in time than anything the Sun has ever owned, passing through the neighbourhood in a single season. And the visitors have changed how we watch the sky. A great new observatory in the mountains of Chile has recently begun surveying the entire southern sky every few nights. an instrument so sensitive that astronomers expect it to catch interstellar visitors not once a decade, but routinely, perhaps a few every year, each one traced back toward a different corner of the galaxy. We are, right now, in the first years of a new kind of astronomy, the study of other solar systems by catching what they lose. Like learning about houses up the street from the leaves that blow into your yard. Let that settle for a moment, because it changes the meaning of the space above you. The emptiness over the solar system isn't empty, it's a road. Other star systems have their leftovers too, their own belts and clouds of icy debris, and gravity is careless with such things, flinging them out into the galaxy where they wander without owners. Some of them are wandering through here, now, above the table, unseen. When you look up at night, you're not looking at a sealed ceiling. You're looking into weather, into a gentle traffic of ancient things passing through. The solar system is not a house with the windows shut. It is a meadow, open to whatever the wind carries. And so you rise higher, following the road the messengers came down, out beyond the swollen donut of the Kuiper belt, out to where the sun itself begins to change. Watch it as you climb. It shrinks. From a blazing disk to a small fierce coin, and then to something that stops the heart quietly, the moment the sun becomes just another star. Bright, yes, the brightest star in a black velvet sky, but a star among stars, one point of light in the crowd. Most of the solar system, by volume, sees the sun this way. We, huddled close to the fire, are the exception. Out here, at distances that make Neptune look like a next-door neighbour, you enter the layer that rewrites the whole map, the layer that was the promise of tonight. Because surrounding everything you've seen so far, the planets, the belt, the visitor's road, there is a shell, the Oort cloud, and it is not flat, it is a sphere. Here is how we know about it, because no telescope has ever photographed it, and it's important to be honest about that. The Oort cloud is real the way footprints make a fox real. In 1950, a Dutch astronomer named Jan Oort sat down with the humblest of tools, a list, a catalogue of comets, the rare long-haul ones that visit the inner solar system once in thousands of years. Oort traced their paths backward, asking each one where it had come from, and the answers formed a pattern too clean to ignore. The comets were falling in from staggering distances, all from roughly the same depth of space, but from every direction. From above the plane of the planets, from below it, from every side equally. If the comets came from a disk, they would arrive along the table like everything else. They don't. They fall in from the whole sky. And the only shape that rains inward from everywhere at once is a sphere. The solar system, Oort realized, must be wrapped in a vast spherical cloud of dormant comets, a shell so distant that its residents had never been seen, announced only by the few that occasionally fall. The scale of that shell is the kind of thing you can only hold for a second or two, like a snowflake on a warm palm. Its inner regions begin roughly 1,000 times farther from the sun than Neptune, and its outer edge lies perhaps 100,000 times the distance from the Earth to the sun, so remote that some astronomers suspect it reaches a meaningful fraction of the way to the next star. Sunlight, which crosses the entire realm of the planets in a few hours, needs more than a year to climb to the cloud's outer shores. Voyager, the fastest long-distance traveller we've ever launched, would need around 300 years just to reach the cloud's inner edge, and tens of thousands more to pass through it. And the population of this shell is almost beyond counting. Astronomers estimate it holds billions upon billions of icy bodies, quite possibly trillions. More comets than there are stars in the galaxy. Yet here is the gentlest fact of the whole night. The Oort cloud is also the emptiest place you will ever hear described. Those trillions of comets are spread through a volume so enormous that each one drifts millions of miles from its nearest neighbour. If you stood on one, you would not see the others. Not one. Just black sky, the far cold stars, and the sun reduced to a bright ember among them, its warmth a rumour from another life. Every comet in the cloud hangs alone in its own private night, orbiting so slowly that a single lap around the sun can take millions of years. It is less like a cloud, really, and more like a held breath, snow that has not yet decided to fall. The shape of the cloud, astronomers suspect, tells the story of its making in one graceful line. Its inner regions, closest to the planets, probably still remember the old flatness, thickened toward the ancient plain like a donut, the last faded loyalty to the spinning disk that built everything. But farther out, that memory dissolves, and the cloud rounds into a true sphere, and the sculptor responsible is wonderful to name. It is the galaxy itself. Out at those distances, the sun's grip grows so faint that the gentle, distant gravity of the whole Milky Way, all its stars and gas together, becomes strong enough to knead the cloud, tugging its outer reaches year after slow year, stirring the flat into the round. The edge of our solar system, in other words, is where the galaxy's hands take over from the sun's. You are floating, right now, through the place where home stops being shaped by home. And the cloud has visitors of its own. Stars do not sit still. They drift around the galaxy on their own errands, and every so often, one of them wanders close. Around 70,000 years ago, while people were already walking the earth, wrapping themselves in furs and telling stories by firelight, a small, dim red star, travelling with an even smaller companion, appears to have brushed right through the outer reaches of our Oort cloud. It would have been far too faint for those ancestors to notice. A visitor sweeping through the hallway of the house while everyone slept. Astronomers found the evidence only recently, by running the star's motion backward like a film, and the calendar of visits runs forward too. Another star, a quiet orange one, is drifting our way now, and in roughly 1 million years it is expected to sail deep into the cloud itself, closer to the sun than the cloud's own outer shores, its gravity rattling the snow globe as it passes, shaking loose, perhaps, a flurry of new comets that will fall toward the light for ages afterward. Whole eras of falling stars, scheduled by a passing stranger. There is even a lonely world that may be a message from the cloud's inner edge. Far beyond Pluto drifts Sedna, a reddish, slow world on an orbit so vast and so stretched that it takes more than 11,000 years to circle the sun once, and never comes anywhere near the planets. Nothing in the known solar system can easily explain how it got there. Some astronomers read Sedna as a native of the inner cloud, a snowflake from the shell's warm side, dislodged long ago and left where we could finally notice it. If so, we have already met a citizen of the sphere, and it is exactly what you'd hope, ancient, unhurried, and a very long way from anyone. And Sedna may not be alone in carrying messages. Astronomers watching the farthest reaches have noticed that a handful of the most distant little worlds seem, possibly, to have their long orbits bunched together, aligned in a way that raw chance shouldn't favour, all leaning as if shepherded by something unseen. One explanation, and it remains only a suspicion, is a planet. A true planet, perhaps several times the heft of Earth, orbiting far beyond everything we've met, on a path tilted well away from the old flat table, so distant that it would take thousands of years to circle the sun once, and would shine dimmer than almost anything we've ever found. Telescopes are hunting for it right now, sweeping the deep sky season after season. It may not exist. The bunching may fade as we find more little worlds. But it is a lovely thing to hold as you drift here. The possibility that the solar system still keeps one large secret, a 9th planet sleeping somewhere in the dark above the map, waiting to be noticed. Sometimes, one of them does fall. A passing star's faint tug, over unimaginable spans of time, tips a comet loose, and it begins the long descent toward the light, a journey that can take 1 million years, gathering speed century after century until it finally sweeps in among the planets, grows its glowing tail, and startles some watching civilization below. The great comets of history, the ones that stretched across the skies of our ancestors, were mostly this: snowflakes from the sphere, finishing a fall that began before humanity existed. You may have already met a visitor from the sphere yourself, and if you were alive in the late 1990s, you almost certainly did. A comet called Hale-Bopp swept in from the deep and hung in the evening sky for month after month, one of the brightest comets in living memory, visible to the bare eye for well over a year. People saw it from cities. People saw it from farms and car parks and school playgrounds, a soft double-tailed smudge of light parked above the sunset, night after night, like a lantern someone forgot to take down. That comet was a snowflake from the shell, most likely dislodged ages ago, finishing a fall thousands of years long. It has swung around the sun now and is climbing back into the dark, and it will not return for thousands of years more. If you saw it, you saw the Oort cloud with your own eyes, one flake of the snow globe passing low over your childhood. So take the picture with you as you rise through it. From far enough away, our solar system is not a disk at all. It is a globe, a little round ornament of ice and quiet, with a warm, flat toy solar system suspended at its centre. We live inside a snow globe, and the flat map was only ever the view from the middle. And the snow globe has a surface we have not yet crossed, because the sun's influence doesn't stop with ice and gravity. Our star fills its whole realm with something like breath, and far above you now, that breath finally reaches its ceiling. The sun does not simply shine, it exhales. From the top of its atmosphere, a thin wind of particles pours outward in every direction, all day, all night, at speeds of around 1,000,000 miles per hour. It is unimaginably sparse, gentler than the gentlest breeze, and yet it never stops, and in the near vacuum of space that persistence is enough. The wind rushes past Mercury, past Earth, where it paints our auroras, past the planets, past the belt, blowing outward for billions of miles, and as it goes it inflates something. A bubble. An immense, invisible bubble of the sun's own breath and magnetism, wrapped around the entire solar system, with everything you have met tonight floating inside it. Astronomers call it the heliosphere, the sun's house in the truest sense, the region where our star's weather is the weather. But every breath meets air that is not its own. The space between the stars is not perfectly empty. It holds a haze of its own gas and dust, thin beyond imagining but real, and as our bubble ploughs through it, the sun's wind eventually slows, piles up, and stops. There is a boundary out there, a place where the outward breath of the sun finally balances against the breath of the galaxy, and inside of it you are home, and beyond it you are not. We know, because we have crossed it. In 2012, the Voyager 1 spacecraft, launched when disco was on the radio, passed through that boundary at about 120 times the Earth's distance from the Sun, and its instruments felt the change directly. The particles of home fell away, the particles of elsewhere pressed in, and a machine built by human hands drifted, for the first time, into the space between the stars. And it did so, fittingly for tonight, while climbing. Voyager 1 is leaving the solar system at an angle, rising some 35 degrees above the plane of the planets as it goes, sailing up and out through the northern roof of the Sun's house. Its twin, Voyager 2, crossed a few years later, heading down instead, below the table, out through the southern floor. What shape is the house they left? Here is a place where honesty is more wonderful than certainty, because astronomers genuinely aren't sure. For decades, the natural guess was a windsock. The Sun is moving, after all, orbiting the centre of the galaxy, so its bubble ought to be blunt in front and streaming out behind, like a comet's tail, like your breath on a winter walk. But newer measurements, including some taken by Ulysses and the Voyagers themselves, have fed computer models that keep producing something stranger and more charming, a plump, rounded, two-lobed shape that the scientists themselves describe as a croissant. Somewhere above you tonight, the solar system's outer wall is either trailing like a banner or curled like a pastry. And the fact that we don't yet know which is a lovely reminder that the map still has blank edges, even the map of home. And when you rise through that wall, out beyond the sun's last breath, you do not fall into nothing, you fall into somewhere. This is perhaps the most beautiful secret of the whole climb. Interstellar space, the black between the stars, has geography. Right now our bubble is drifting through a wisp of interstellar haze that astronomers call, with real affection, the local fluff, a loose cloud of gas a few dozen light years across, so tenuous it makes the best laboratory vacuum on Earth seem crowded, and the fluff itself floats inside something far grander. For the last several million years, the Sun and everything it owns has been gliding through the interior of a colossal cavern in the galaxy's gas, a hollow some 300 light-years wide, known as the local bubble. The local bubble is a scar. 10 to 20 million years ago, in this region of the galaxy, a family of giant stars lived fast and died spectacularly, one supernova after another, each explosion shoving the surrounding gas outward like a plough. Together they swept this whole neighbourhood nearly clean, leaving behind a cavity of gas so thin and so hot that it barely counts as matter at all. A few wisps of million-degree emptiness where a bedroom's worth of space might hold fewer atoms than there are people in a small village. That is what is directly above your ceiling once you climb past the sun's bubble. Not a void, a cathedral. The hollowed interior of ancient explosions, its walls made of all the gas the dead stars pushed aside, and our little snow globe drifting through the middle of it like a firefly crossing a dark hall. The wind that inflates our bubble has its own bedtime-worthy story, because when it was first proposed, almost nobody believed in it. In the late 1950s, a young physicist in Chicago named Eugene Parker worked out, on paper, that the sun's atmosphere could not simply sit still. The arithmetic said it must be flowing outward, everywhere, always, a wind filling the whole solar system. The idea sounded so wrong to his elders that the reviewers of his paper recommended rejecting it outright, and it survived only because the journal's editor, a stubborn man named Chandrasekhar, could find no error in the mathematics and published it anyway. Within a few years, the first spacecraft flew above the atmosphere, tasted space directly, and there it was. The wind, exactly as the young man's equations had whispered. Parker lived to see a spacecraft named in his honor launched toward the sun itself, and he watched it rise, the first person in history to attend the launch of a machine bearing their own name into space. Every aurora you will ever see, by the way, is that wind arriving. When the green curtains ripple over the poles of the Earth, that is the sun's breath, caught and funneled by our planet's magnetism, glowing as it rains into the high air. The bubble touches us gently on winter nights. And the bubble's far walls, it turns out, are stranger than anyone guessed. Long before the boundary itself, the wind tires. Somewhere out past the planets, it abruptly slows from its million-mile-an-hour sprint to a comparative stroll, piling into itself like highway traffic meeting a hill. And beyond that lies a vast, slow region where the sun's breath drifts and eddies, no longer racing, not yet stopped. Both voyagers felt that crossing on their way out. And when a small Earth-orbiting observatory called IBEX made the first full map of the boundary region, sensing it by the particles that come back from the edge, the map held a surprise no one had predicted. A great bright ribbon of activity arcing across the sky of the boundary, a glowing seam in the wall of the house. Scientists have spent years puzzling over exactly what shapes it, and the honest status is that the wall of the solar system has a decoration on it that we are still learning to read. Even the edge of home keeps a little mystery for itself, and here is something to feel grateful for as you drift along the bubble's high ceiling. The heliosphere is not just the sun's territory. It is the sun's shelter. The galaxy outside is laced with cosmic rays, fragments of atoms flung to ferocious speeds by ancient exploding stars, a thin, fast rain that falls from every direction, forever. The sun's bubble turns a great deal of it away. The outward breath and its tangled magnetism act like a deep porch roof in a storm, deflecting a large share of the galactic rain before it can ever reach the worlds inside. Down on Earth, beneath the further shelter of our own magnetic field and our thick, kindly atmosphere, so little gets through that you can sleep beneath the whole affair without a thought. But it's happening tonight, all the same. Far above you, at the edge of the sun's house, the weather of the galaxy is breaking against the roof, and the roof is holding, the way it has held for 4.5 billion years, long enough for oceans, and forests, and you. One more note for the travel diary, and it is a gentle one. The local fluff, the wisp of interstellar haze we are currently passing through, will not last. Measurements suggest our solar system entered it only recently, as the galaxy counts time, and that we are drifting toward its edge. Some thousands of years from now, the sun's bubble will slide out of the fluff entirely and into whatever wisp comes next, and the boundary above your head will shift and resettle, the way a sleeping person adjusts beneath a blanket. The solar system is not parked. It is underway, on a voyage through changing weather, and always has been. And the cathedral is not dead. In the last few years, astronomers mapping the bubble made a discovery that turns the whole story tender. The compressed gas of the bubble's walls, the rubble shoved outward by those long-gone stars, is condensing. It is making new stars. Nearly all the young stars being born near us today sit on the surface of the local bubble, in the piled-up wreckage of the old ones. The deaths that emptied this room are furnishing the next one. When you rise above the solar system, this is the neighborhood you enter. A place where endings quietly turn into beginnings, on a schedule of millions of years, with no one in a hurry at all. So now you have risen through every roof the sun can claim. The table of planets, far below, would fit behind a grain of sand held at arm's length. The snow globe of comets is a soap bubble beneath you. Even the sun's great breath is behind you now. Surely, you might think, up is finished. But it isn't. And here is the twist that carries us into the next part of the night. All this time, while we climbed above our little table, we have been standing on another one, a table so much larger that we forgot to notice it. The way you can forget the floor of the world while studying the table in your kitchen. Because our sun, and the local bubble, and every star you have ever seen with your own eyes, all of it sits inside another disk, the galaxy. And the galaxy has its own above and below. The Milky Way is a disk of a few 100 billion stars, 100,000 light-years across, and it is flat for exactly the same reason our solar system is flat. It spins. The same old story, written 1 billion times larger. A vast cloud, an ancient turning, a great collapse into a plane. Spirals of stars and glowing gas, all orbiting a shared center, all keeping, loosely, to a shared sheet. Our sun rides that sheet about 26,000 light-years from the middle, out in the calm suburbs, carrying us around the galaxy once every 230 million years or so. The last time we were here, at this point in the orbit, the very first dinosaurs were just learning to walk. It's worth knowing your address in this city of stars, because it's a modest one, and all the better for sleeping. We do not live on one of the galaxy's great glittering boulevards. The Milky Way's brightest structures are its spiral arms, long crowded avenues of starbirth and blue light sweeping around the disk. Our sun lives between two of them, on a quieter side street astronomers call the local arm, or sometimes the Orion spur, a smaller ridge of stars threading the gap between the grand avenues. It is, honestly, a wonderful neighborhood for a sleepy little solar system. The great arms are busy places, thick with young giant stars that live loud and end explosively. Out here on the side street, the traffic is calm, the neighbors are settled, and nothing dramatic has happened close by for a very long time. When you picture your cosmic address tonight, picture lamplight on a quiet lane, 2 blocks from the parade. And now, the detail that might be my favorite fact of the entire night. The galaxy's table and our table do not agree. The plane of our solar system is tipped about 60 degrees to the plane of the Milky Way. 60 degrees. Our little dinner table leans against the galaxy's great floor like a painting propped steeply against a wall, which means that everything we have called up tonight, the direction over the sun's pole, the axis of our snow globe, is not the galaxy's up at all. The 2 ups point in different directions entirely. You can see this disagreement with your own eyes on any clear dark night, and you may have seen it without knowing. The band of the Milky Way, that soft river of light, does not follow the path of the planets across the sky. The 2 roads cross at a steep slant. That slant is the truth of our crooked seating, visible from any dark meadow on Earth. And since we're being honest about tables tonight, here is a confession about the galaxies. It isn't perfectly flat either. When astronomers recently charted thousands of pulsing stars scattered across the Milky Way, stars whose blinking lets us measure their distances precisely, the map that emerged showed the great disk gently bending at its far edges, one side curling up, the other dipping down, like the brim of a well-loved hat, like a vinyl record left leaning in the sun. The galaxy's table warps, most likely tugged over the ages by the gravity of its own satellites and neighbors. So even the grandest floor we know has a wave in it. Nothing in the universe, it seems, can resist leaning just a little. The disk also keeps a memory of rougher times, mixed through the galaxy, moving against the grain of the calm majority. Astronomers have found great shoals of stars that all travel together, strangers with matching stride, and their shared motion is a fossil. Long ago, many billions of years back, a smaller galaxy fell into ours and was folded in completely, its stars scattered through the Milky Way like a spoonful of cream stirred into coffee. Part of the puffy, older disk we passed on the way up may be the splash of that ancient landing. The galaxy above and below us is not just a structure, it is a history, still faintly legible, of everything it has ever absorbed. And it was by watching disks like ours that we first learned of the great invisible presence wrapped around them. In the 1970s, an astronomer named Vera Rubin sat night after night measuring how fast the stars in other galaxies swing around their centers, expecting the familiar pattern of any orbit, fast near the middle, slower toward the edge, the way Mercury hurries and Neptune strolls. That is not what she found. The outer stars were moving just as fast as the inner ones, everywhere she looked, as if every galaxy's suburbs were being carried by something unseen. Either the arithmetic of gravity was wrong, or every galaxy held far more matter than its light revealed. Her patient, unglamorous measurements became one of the great turnings of modern science, the strongest early evidence for dark matter, the invisible majority of the cosmos. The halo you are rising through was discovered not by seeing it, but by noticing that the visible world dances too fast to be dancing alone. And there is one more secret in the galaxy's floor. We are not resting on it. We are bobbing. The sun, carrying all of us with it, does not glide levelly around the galaxy. It drifts slowly up through the galactic plane, and the combined gravity of the disks, stars and gas gently pulls it back, and it sinks through to the other side, and is pulled back again, over and over, a slow, colossal breathing. Each full rise and fall takes tens of millions of years. Roughly every 40 million years or so, give or take, we pass through the crowded middle of the sheet. And right now, tonight, the whole solar system is somewhere around 60 to 100 light-years above the galaxy's midplane, and still drifting gently upward, like a carousel horse partway through its rise, like a sleeper's chest mid-breath. Scientists, being scientists, have wondered whether those long crossings of the crowded midplane ever mattered to life down here, whether passing through the galaxy's dustier lanes might jostle the Oort cloud or dim the neighborhood in ways a planet would notice, and whether any of Earth's ancient upheavals line up with the rhythm. It's a fair question, and the honest answer, so far, is that the evidence stays thin and the idea remains a wondering. The crossings are slow, the disk is mostly empty even at its thickest, and our planet has sailed through many of them without any clear scar, so you can hold the image without any shiver. The galaxy breathes, and we breathe with it, and in all the time there have been creatures on Earth to feel anything at all. The ride has been smooth. You have been riding that motion your entire life. Every night you have ever slept, you are also, in the largest sense, slowly ascending. So rise, one more time, and leave even the galaxy's table below. What lives above the Milky Way? The first thing you pass is more Milky Way, thinner and older. The bright young disk floats inside a puffier, fainter disk of elderly stars, the galaxy's earlier drafts, and above that begins the halo, a vast, dim, roughly spherical realm wrapped around the entire spiral. The halo is where the galaxy keeps its eldest things. Sparse, ancient stars drift up here on long, tilted orbits, stars so old they formed before the disk itself existed. Wanderers that dive through the bright sheet and soar high above it. The way the Oort cloud's comets wrap our little solar system. The pattern of the night, you'll notice, is repeating itself at every scale. Flat, busy middles, round, quiet, ancient outsides, and hanging in that halo are some of the most beautiful objects the universe makes, globular clusters. Each one is a ball of hundreds of thousands, sometimes millions, of stars packed into a sphere so dense that its heart never knows true night. More than 150 of them orbit our galaxy, above the disk, below it, all around it, like chandeliers hung at every height through some impossible ballroom. They are among the oldest structures we can see, many of them nearly as old as the universe itself, and they have been circling the galaxy since before the sun was born, dipping through the bright floor and climbing away again, patient as tides. You can visit one of those chandeliers yourself, by the way, any clear summer evening in the northern hemisphere. In the constellation Hercules hangs a globular cluster that astronomers call, plainly, the Great Cluster, and through simple binoculars it appears as a soft, round glow, like a dandelion head made of light. A modest backyard telescope begins to resolve it into stars, hundreds of them at the edges of a luminous crowd of hundreds of thousands. What you are seeing, when you find it, is a city of suns hanging more than 20,000 light-years above the galaxy's floor, older than the sun, older than almost everything, drifting through the halo on an orbit that has carried it over and under the disk since before there was an Earth to watch from. It is one of the easiest ways there is to look at something above the galaxy, and it costs nothing but a summer night and a little patience. Farther out, the galaxy has company. Small satellite galaxies orbit the Milky Way the way moons orbit a planet. The two largest, the Magellanic Clouds, hang off to one side of the disk, far south of the galaxy's floor, and on dark nights in the southern hemisphere you can see them with your bare eyes, two soft glowing smudges, like breath on a cold window, each one a small galaxy of its own, billions of stars keeping us company from 160,000 light-years away. And one little satellite, a faint smear of stars called the Sagittarius Dwarf, is in the middle of being slowly, gently absorbed, its stars pulled into long ribbons that loop above and below our disk, streams of suns wrapping the galaxy like loose thread. Looking at those streams, astronomers can read the story of a small galaxy dissolving into a big one, over billions of years, without a single collision between stars, everything simply drifting apart and folding in. And all of it, the disk, the halo, the chandeliers, the ribbons, floats inside something we cannot see at all, the dark matter halo. Astronomers can weigh the galaxy by watching how fast its stars swing around the center, and the arithmetic comes out plainly. There is far more holding this galaxy together than everything we can see combined. Whatever that unseen substance is and nobody yet knows, it forms an enormous invisible sphere around the Milky Way, vastly wider than the disk of stars, the true body of the galaxy, of which all the light we see is only the glowing center. Above the galaxy, in other words, there is more galaxy, just none of it shines. If you point yourself straight up out of the Milky Way's disk, up through the halo, toward the galaxy's own north, you are aiming at a quiet patch of sky near a modest constellation called Coma Berenices, named for a queen's sacrificed hare. There is no great beacon there, no marker, just a soft scatter of faint stars, and beyond them, a doorway of clean dark sky where the dust of our galaxy thins away and the universe opens. Astronomers love that direction, for exactly that reason. Looking up out of the disk is looking through the cleanest window the galaxy has, so go through it. Now the Milky Way is below you, whole. A slow silver spiral, 100,000 light-years of stars turning like a galaxy-sized weather system, and around it, black distance, and in that distance, others. Andromeda, our great neighbour, a spiral even larger than ours, its light 2.5 million years old by the time it reaches your eyes. The dozens of small galaxies of our local group, drifting together in a loose gravitational family a few million light-years wide. And beyond the family, the crowds. Tens of millions of light-years away rises the Virgo cluster, a swarm of 1,000 galaxies packed into one region of sky, and our little group is one of countless outlying villages tied loosely to its gravity. Whole galaxies, from up here, become what stars were at the beginning of the night. Points, grains, population. Andromeda deserves one more moment before we rise past it, because it holds a small record that belongs, in a way, to you. On a dark autumn night, far from city lights, Andromeda is visible to the naked eye, a faint elongated smudge, easy to miss, unmistakable once found. It is the farthest thing an unaided human eye can ordinarily see. When you look at it, light that left an entire other galaxy before our species existed completes its 2.5 million year journey by landing on the back of your eye. Your body becomes the finish line of the longest voyage you will ever personally receive. People sometimes describe stargazing as looking up at the universe, but it's truer to say the universe is arriving, constantly, gently, onto anyone who tilts their head back. Sight is a form of touch across impossible distances, and Andromeda is the farthest thing you will ever touch. And the grains have a shape. This might be the most astonishing single image the universe offers, so hold it gently. When astronomers map millions of galaxies, marking each one as a dot of light, the dots do not scatter randomly, like spilled salt. They gather. Galaxies collect into threads, and the threads weave into a network, immense glowing filaments millions of light-years long, meeting at bright knots where clusters live, with vast dark hollows caught between them. The universe, at the largest scale we can see, looks like a web, like foam, like the delicate structure inside a loaf of bread, walls of light around bubbles of dark. Our Milky Way, our local group, the Virgo cluster, and 100,000 galaxies besides, all belong to one colossal strand of that web which astronomers have named Laniakea, a Hawaiian word meaning immeasurable heaven. That is your address at this height, one bright thread of an endless net called immeasurable heaven. Between the threads lie the voids, and the voids deserve a moment of respect, because they are the true above and below of the universe. These are the bubbles of the cosmic foam, regions 100 million, 200 million, 300 million light-years across, containing almost nothing. The greatest of the nearby ones, the Boiter's void, is so large and so empty that if our galaxy had formed at its centre, we would have looked out and seen blackness, and might not have discovered that other galaxies existed until deep into the modern age. The voids are the quietest places in existence, not sinister, just still. The universe, it turns out, is mostly made of these silences, held apart by walls of galaxies, the way a sleeping house is mostly quiet rooms, held together by a few lit hallways. It's worth pausing on how recently all of this was invisible. Barely a century ago, respectable astronomy held that the Milky Way was the entire universe, and that the little spiral smudges in telescopes were nearby wisps of gas. Then Edwin Hubble, working with the Great Telescope on Mount Wilson, found blinking stars inside the Andromeda smudge, measured their distance, and quietly ended that universe. The smudges were other galaxies, million-year journeys away, and within a few years came the deeper shock. The distant galaxies, nearly all of them, are receding from us, and the farther they are, the faster they recede. Not because everything is fleeing some explosion in space, but because space itself is stretching, carrying the galaxies apart the way rising raisin bread carries its raisins away from one another. Every raisin seeing every other raisin drift off. No raisin at the centre, because there is no centre to rise from. The web you are floating above is not sitting still. It is gently, evenly, growing. Within the web, though, gravity still writes local stories. Our own thread has a current in it. The galaxies of Laniakea are not scattered at random. Their drifting motions, when astronomers chart them, flow like streams on a watershed, all trending toward a distant gravitational lowland, a great concentration of matter whose pull organizes the whole neighborhood, the way every brook on one side of a mountain range finds its way toward the same valley floor. That drainage pattern is, in fact, how Laniakea's borders were drawn. A supercluster is simply everywhere whose galaxies would, given forever, flow to the same place. Our Milky Way is one droplet on that watershed, sliding, unhurried, along its thread. And in the other direction of fate, Andromeda and our galaxy are drifting toward each other, and in about 4 or 5 billion years, long after the sun has grown old, the two great spirals will sweep through one another again and again until they settle into a single vast galaxy, their stars almost never touching, whole star systems passing through one another like two crowds crossing a plaza, blending into one. Even collisions at this scale are gentle, and the voids are not quite perfectly empty, which somehow makes them lovelier. Deep surveys have found the occasional galaxy adrift far inside a void, alone in a way nothing else in the universe is alone. A single lit farmhouse in a county-sized darkness, no neighbours, its night sky nearly starless beyond its own suns, and almost galaxyless beyond that. Astronomers prize these hermit galaxies because they grew up undisturbed, but it is hard to read about one without a pang of tenderness. If beings on such a world ever built telescopes, their first discovery of another galaxy would come very late, and would land like a letter from beyond the edge of everything they had ever conceived. And now, the last layer, because even the web is not the top, rise above Laniakea, above the voids, imagine yourself higher than any structure at all, and ask the question of the night one final time. What is above all of this? Here is the answer the universe gives, and it is the strangest and gentlest one yet. In every direction you look, up, down, every side, at the very limit of seeing, there is light. The same light everywhere. A faint, ancient glow, arriving from all sides at once, from farther away than every galaxy, the leftover warmth of the beginning itself. Astronomers call it the cosmic microwave background. It has been travelling for nearly 14 billion years, since the universe was young and glowing everywhere at once, and it's cooled on the journey to just a couple of degrees above the coldest anything can be. It is the oldest thing that can be seen, and it is the wallpaper of the sky. And we found it by accident, in one of the sweetest stories science owns. In the 1960s, two radio engineers in New Jersey, Arno Penzias and Robert Wilson, were trying to calibrate a large horn-shaped antenna, and they could not get rid of a faint hiss. It came from every direction. It came at every hour, every season, wherever they pointed. They checked the wiring. They checked the nearby city. They famously evicted a pair of pigeons roosting in the horn and scrubbed away what they gently recorded as a white dielectric material. And still, the hiss remained. It took a conversation with physicists up the road at Princeton, who had been preparing to search for exactly such a signal, for everyone to realize what the antenna had been hearing all along. The two engineers had stumbled onto the afterglow of the beginning of the universe. The static between the stations, it turned out, was partly the Big Bang itself, still whispering. They received the Nobel Prize for it, and the pigeons received an eviction they never understood. Behind the last galaxy, in every direction, the beginning is still faintly shining. How far away is that final wallpaper? The light itself has travelled for nearly 14 billion years, but space has been stretching beneath it the whole way, carrying its birthplace farther as it flew, so the region it set out from now lies unimaginably deeper than the light's own age suggests. Add it all up, and the bubble of everything we can see, the observable universe, spans something like 93 billion light-years from side to side. And the word observable is doing gentle, honest work in that sentence. It is not the size of the universe. It is the size of our view, the distance across which light has had time to reach us since the beginning. Beyond that horizon there is, as far as anyone can tell, simply more. More web, more voids, more threads of galaxies, continuing on past the edge of our seeing the way the ocean continues past the round horizon of a ship. No wall has ever been found, and none is expected. The universe does not seem to end. Only our view does. And notice what that means. Look up from here, and you see the glow. Look down, past your feet, through the web, and you see the same glow. The universe has no attic and no basement. Every direction ends at the same beginning. Measure it any way you like, and the story comes back the same. The universe, at the grandest scale, has no grain, no favoured direction, no axis, no top. Up here, the question we packed at the start of the night finally comes apart, and it comes apart beautifully. There is no up, there is no down, there is only outward, in every direction equally, and everything there is, floating in the middle of it. So let the whole journey settle into place, because here at the top, you can finally see what above and below really were. They were never properties of the universe. They were properties of tables. Every up we found tonight belonged to something spinning. A young solar system spun itself a plane, and up meant away from it. A galaxy spun itself a grander plane, tipped 60 degrees from ours with its own up. Every disk in the cosmos carries its own private compass. Each one local, each one temporary, none of them agreeing, all of them lovely. And between and beyond them all, the universe itself holds no direction at all. Nothing above you tonight is hanging over you. Nothing beneath you can give way. There is no ceiling to press down and no floor to fall through, no cellar, no attic, nowhere for anything to drop. The cosmos cannot fall anywhere, which is why, after almost 14 billion years, it is still simply calmly here. And so we come home. Down through the ancient light, down along the bright thread of immeasurable heaven, past the still rooms of the voids, down to the slow silver spiral, and in through its clean northern window, past the chandeliers of the halo, down onto the great turning floor of stars, riding the gentle rise of our bobbing Sunday, down through the cathedral walls of the local bubble, in through the croissant curve of the sun's own breath, into the snow globe, past the trillion patient snowflakes that will not fall tonight, down through the donut of frozen sparks, past the leaning orbits of Eris and Pluto, through the soft glow of the zodiac dust, onto the thin, bright table of the planets, to the third one from the sun, to your country, your town, your street, your roof, and the quiet room where you are lying right now, in a bed that has been sailing through all of this the entire time. Straight up through your ceiling, it is all still there. The tilted wanderers and the sphere of sleeping ice, the bubble carved by old stars and the slow breathing of the galaxy, the web of light and the rooms of silence and the glow of the beginning, stacked above your pillow tonight, in the direction no map ever shows, asking nothing of you at all. You live on the calmest kind of world there is, one with a warm floor beneath you and no ceiling above you, anywhere. The stars will keep spinning while you sleep.